And this is 2018, and this is question 8, leaving cert higher level part A that we're going to start with, and then f of x is equal to 1 over root 2 pi e minus a half x squared. So find the coordinates of A, the point where the graph intersects the y-axis. So where something intersects the y-axis, x will be 0. So let x equal 0. So if we let x equal 0, we'll get 1 over root 2 e to the power of minus a half by 0. So that'll just be 1 over root 2 e to the power of 0, and anything to the power of 0 is 1. So that'll just be 1 over root 2 pi. And then the coordinates, well, the x point will be 0, so the y point will be 1 over root 2 pi. So that's going to be the coordinates where it crosses the y-axis. And then it says the coordinates of, I'm just going to draw out a diagram. So this is not a great diagram, but it'll do. So we're told the coordinates of B are minus 1, so minus 1 across on our x-axis, and then 1 root 2 pi e on our y-axis. Well, we want to get the area of this shaded region, and we're told it's symmetric. So, well, the length here is going to be, well, if that's a jump of 1 to get to here, well, then this whole length here is going to be 2, and the height here is going to be this here. So the area of the shaded rectangle is going to be 2 multiplied by the height, which is 1 over root 2 pi e. So then we get 2 over 2 root pi e. So that's our answer for that. So that's the area. And then it says use calculus to show that it's decreasing. So if we want to show that, so if we get the slope of something and show that the slope is negative, so the slope is dy dx or f dash x. So firstly we have to differentiate this. So 1 over root 2 e. So if we're differentiating this in terms of x, the only thing that we're going to need to differentiate is anything that has an x. So because this is a constant, we don't have to touch that. So we have to, I know that if I differentiate e to the power of x, say this is I'll just get e to the power of x. But with the chain rule, if I have something like e to the power of 5x, well, firstly, to differentiate that, it's still going to be e to the power of 5x. But then I have to multiply this by the differentiate of this, so it's going to be multiplied by 5, so it's going to be 5e 5x. So now we're going to go with this one. So the half 2 pi isn't going to change, and then e to the power of minus a half x squared. So it's still going to be a half 1 over root 2. The e is going to still have the same power, but we are going to have to differentiate this power. So if we differentiate this power, so say if we just had a half x squared minus a half x squared. So if we differentiate that, the 2 will come to the front, so it will be minus 2 over 2x. So that's just going to be minus x. So you have to multiply this by all by minus x. So then it's going to be 1 over so I'll just put a minus in front, and then x e minus a half x squared. So it's decreasing at c. So I'm going to have to put in my x value at c. So my x value at c is 1. So minus root 2 pi, and then it's just going to be x is 1, so it'll just be 1 minus a half. So this is always going to be negative, so it is less than 0. So the slope, because the slope is less than 0, it's going to be decreasing. So then that's that one. And show that the graph has a point of inflection at B. So to show that something it has a point of inflection, I'm going to have to show that the second derivative is equal to 0 at B. So I'm already after getting the first derivative. The first derivative which I got is minus 1 over root 2 x e. So now if I want to differentiate this, I have to figure out, well, what has x's, because the things that have x's in them have to be differentiated. So well, I'm just looking at this. Well, there's an x here and there's an x in this power. So that's one thing with an x multiplied by another thing with an x. So I'm going to have to use the product rule because there's one thing with an x multiplied by another thing that also has an x. So first, I'm going to call my u minus a half minus this x. I'm going to call this u, and then I'm going to call my v e to the power of minus a half x squared. So if I differentiate this, I'm just differentiating in terms of x, so x will go to the power of 0, and then that'll just be, so du dx is going to be minus 1 over root 2 pi, and then dv dx it's just going to be the same as the last time. So I have to, the e is still going to be the same, still going to have the same power, but it's going to be multiplied by the derivative of this. So the derivative of that we already got was minus x. So say if we had minus a half x squared, so the 2 will come in, so it'll be minus 2 over 2x, so minus x, so we multiply that by minus x. So dv dx is equal to minus x e power of minus a half x squared. So this part is just a bit on the side. So now I have to plug it in. So my product rule is dy, I'm just going to write out dy dx is equal to u dv dx plus v du dx. So I already figured out my u, I have my du dx, and I have my dv dx and my v. So u I got was this, so I'm going to plug that in. So minus 1 over root 2 pi, and then x, so my x is on the top of the line, and then dv dx was this one here, so minus x e, and then minus a half x squared, and then plus v, which is this one here, plus e to the power of minus a half x squared, plus du dx, plus this, so minus 1 over root 2. So I'm just going to put, so that's a minus by a minus, it's going to be a plus, so 1 over root 2, and that's x by x, so that's going to be x squared, e to the power of minus a half x squared, and then that's going to be minus 1 root 2 pi, and then e to the power of minus a half x squared. So I was asked to show that, so this is my second derivative, and I was asked to show that at b I have a point of inflection. Well, if I want to show that I have a point of inflection at b, I have to show that my second derivative at b is equal to 0. So the coordinates of b are minus 1, the x coordinate of b is minus 1. So I have to sub in x for minus 1 for x and show that that's 0. So I get 1 over root 2 pi, so minus 1 squared, so that's just going to be minus 1 squared. So then e to the power of minus a half minus 1 squared, and then minus 1 over root 2 e to the power of minus a half, and then minus 1 squared. So I'm just going to move on to a different page, so I'll just hold that down. So then we get so I'll just get a pen to pull that down. So then we get minus 1 over root 2 pi, sorry, and then minus 1 by 1 is just going to be plus 1, so that's just going to be e, and then it's going to be minus a half, because minus 1 by minus 1 is just going to be plus 1, and then minus 1 over root 2 pi e, and then to the power of minus a half. Well, that's just one thing, minus itself, so that's going to be 0. So I've shown that my second derivative at b is 0, and that is our answer. Thank you.